With that, Group 9 presents their final year project. Our topic is Life Cycle Assessment of Self-Compacting Concrete, Incorporating Nano-Silica and Recycled Aggregates. Proceeding to the contents, we'll have an introduction first. Afterwards, we'll continue with the problem statement, methodology, which includes all the procedure and mix proportions, results and conclusions, and finally some references that helped us with this research. Starting off with the introduction, we can divide our topic into 4 parts. Life cycle assessment is basically assessing the project's impact throughout its life cycle. Self-compacting concrete, as its name suggests, does not require compaction since it is highly workable. It was formed in 1980s in Japan due to shortage of labor, and presents a number of benefits as shown. However, it has some cons as well, the major one being its cost. Use of aggregates from demolished buildings and recycling them presents a number of benefits. Recycling costs are lower than mining of natural aggregates. It has little environmental effect and reduces space wastage in landfills. Let's talk about something that has been getting more and more attention these years, Nano-Silica. Its high surface area to volume ratio allows it to fill the spaces between CSH gel. As a result, it helps in increasing strength. However, it does require more water to retain its workability. Moving on to the problem statement, let's clarify what the real problem is. According to SCSS, the construction industry is the major consumer of total energy and raw materials. Moreover, the greenhouse gas emissions and solid waste generation are up to a massive 40%. To counter this issue, nanoparticles that reduce the carbon dioxide emission are being focused on throughout the world right now. This project uses SCC to save energy used in compaction. It uses RCA to preserve raw materials and reduce waste, and uses NS to increase sustainability and promote green construction. The objective of this project is to investigate the influence of Nano-Silica as an additive in SCC incorporating recycled aggregates, to compare properties of fresh and hardened form of SCC with and without NS, to observe difference in properties by comparing results on SCC with Nano-Silica that does not incorporate recycled aggregates. Here are the 12 mixes we designed that we will be working with. As you can see, we used 0, 25, and 50% of recycled aggregates, and for each one, we will be adding 0, 2, 4, and 6% of Nano-Silica. As you can see the names, RA0 NA0 means 0% of recycled aggregates and 0% of Nano-Silica. Here is the sieve analysis, of course, and fine aggregates before we get into the mixes. To meet SCC requirements, we made a number of trial mixes with variable percentage of superplasticizer. At 1.1%, we were able to meet the acceptance criteria. These materials will be used in our research, and the methodology followed is according to this flowchart. Mix proportions, followed by trial mix, then 3 SCC tests, and if they are within these limits, further tests are conducted. Then quantity takeoff followed by optimization, and finally the life cycle assessment. Compressive, flexural, and split tensile tests on hardened concrete and durability tests will be carried out on each mix design after fresh concrete and material tests provided us with the quantities shown earlier. Finally, the results of compression test after 28 days for each mix are shown above. For better understanding, let's move on to the chart. As you can see, increase in Nano-Silica resulted in more compressive strength, however. With 0% of RCA, 2% of Nano-Silica showed the greatest increase. For 25% of RCA, the greatest increase was at 4%. Using 50% of RCA showed a negative affect on properties of concrete. You can also view the relative percentages with respect to the control mix. These are the values of split tensile strength. Note that the lowest value is of mix design 9, that has 50% of recycled aggregates and 0 Nano-Silica, while the highest strength is achieved by mix design 8 with 6% Nano-Silica and 25% recycled aggregate. The graph shows a similar trend as compressive strength. Split tensile strength took a dive as well when RCA was added at 50%. The rise trends are again similar. Coming on to the flexural test results, we can see that increasing Nano-Silica increased the flexural strength, and 25% of recycled aggregates usage further increased the values. Moreover, the loss from using 50% of recycled aggregates is compensated by 4% of Nano-Silica, which equals it to the control mix. Here's the graph with similar trends as the previous two. To sum up the research, SCC had similar results to ordinary concrete, with minor differences in the properties when compared to other research papers. With 0% of recycled aggregates, increase in Nano-Silica achieved better compressive, flexural, and split tensile strength, with the best result at 0 to 2%. When recycled aggregates are added to 25%, minor increase in properties is observed with best increment at addition of 2 to 4% of Nano-Silica. Increasing recycled aggregates to 50% had a negative effect on concrete's compressive, flexural, and tensile strength. Additional use of Nano-Silica in about 4% negated the negative effect when RCA is used in 50% and showed better results than 0% Nano-Silica and 0% RCA when it was increased to 6%. Moving on to the socio-economic benefits, we were able to target 5 of the 17 sustainability goals. SDG number 9, Industry, Innovation, and Infrastructure. We were able to add NS and RCA to SCC, that is a new concept. SDG number 11, Sustainable Cities and Communities. NS with 25% of RCA showed more strength and more durability. SDG number 12, Responsible Consumption and Production. Using RCA reduces waste from demolished sites and conserves natural aggregates. SDG number 13, Climatic Action. Instead of using additional cement for high strength, Nano-Silica helped in reducing greenhouse gas emissions. SDG number 15, Life on Land. Saving more land from dumping of used aggregates and recycling them for future projects. We are still working on the last 2 stages of our project, and will hopefully share the results soon. These are some of the references of the research papers that helped us in conducting this research the most. Thank you for taking out time to see our project.